All right. Hey, everyone. So I'm Brent Vatne. I live in Vancouver, Canada. I work with some really brilliant people at this company called Exponent. Don't really have a lot of time to talk about Exponent itself here, but check us out at getexponent.com. At Exponent, we recently worked with a partner company called List. It's founded by the actor, author, writer, comedian BJ Novak, who you might know as Ryan from The American Office. About a month ago, we launched the Android version of List, and it was built entirely with React Native. The app was featured on the Google Play Store. It was discussed at TechCrunch Disrupt, on The Colbert Show, The Today Show, and The Daily Show, and now at React Europe, so that's good. Good company. List for Android is entirely written in JavaScript. So we didn't write any custom native views for it. And I think this is a really important distinction because with React Native, you can write as much or as little of your app as you like using JavaScript. And you can write native code wherever you want as well, and that mixes and matches really well. So the canonical example in the React Native community, I think, of bridging and including a native view inside your app is the chat feed in the Discord iOS app. So I don't know how many of you use Discord, probably a decent amount because of the Reactive Flux community, but their iOS app is built using React Native, and the chat feed, it's currently not possible to build a good performing chat feed in just JavaScript and React Native, and so you actually have to bridge a native view for that. And so that's what was done here. But we didn't do any of that in List. So I think perspective is really worth a lot. So what I hope to do today is give you some insight into the perspective of someone who's really spent every working day over the last year and some months working with React Native, and specifically over the last few months building List. Okay, so the first topic is going to be lists and incremental and lazy rendering. There we go. So some of the most important screens in most apps look something like this, except obviously without the placeholder content. And what you see here is a list view. So if we look at List itself, and I'm sorry for the overlap in the name of List and ListView. Yeah, nothing I could do about that. This is something that we use everywhere. And it's really important because this is one of the primitives, and for a long time for React Native, the only primitive that was available for facilitating incremental rendering. So let's take a step back and define incremental rendering. We're going to have a look at how the JavaScript code is executed in React Native, sort of at a high level, but hopefully it'll help facilitate some understanding. What we have here is a touch event coming in. The user releases a touch from the screen, and that's handled by React Native's touch handler. The touch handler calls receive touches on the native event emitter, and passes along the native touch data. So then the event emitter asks the bridge to enqueue this, firing this event, and the bridge obliges. When the queue is ready to execute, the function is then executed on the JavaScript thread. It's sort of evaled through something called call function return flushed queue, which, as you can guess, once it's done calling the function, it's going to return a flushed queue. And once that happens, right, the regular JavaScript execution is starting to take place. So it calls the event emitter for us, which goes through the responder system, determining which component should have this event firing on it. Ultimately, that fires on press somewhere, which then, let's say in this case, results in set state. And maybe that produces a bunch of commands to create, update, rearrange different views somewhere on the screen. And those are all put into this JS to native message queue. And once that's done, we take all these commands, we serialize them, and then we send them over back to the JavaScript side. Then these are deserialized and executed using something called UI Manager in this case. Okay, so that's roughly how code is executed. So let's go back to the slide where we are actually doing the rendering, and imagine that we are blocked for 2 seconds in rendering this. So we're rendering a lot of stuff. So if that happens, and then very soon after we start doing this rendering, a timer expires, that timer will be put into the executor queue, but it actually won't be able to execute on the JavaScript thread until all this other rendering is complete. So JavaScript doesn't allow us to just temporarily interrupt execution. If this was a very important event, like a touch event that we want to respond to immediately, there's nothing we could do. We have to wait at this point. And so this is known as cooperative multitasking. So incremental rendering in the context of lists means that rather than rendering all of the views in your list up front and blocking the thread for this huge amount of time, and also potentially creating a bunch of unnecessary views, what we do is we chunk it into smaller pieces and occasionally yield. So maybe we render for 150 milliseconds, and then we yield and wait for the next frame, and then render again, et cetera. And so, yeah, after that happens, right, we serialize them, return it to get executed, et cetera, and can handle the next task. So let's just skip past that. So looking at the ListView, as I was saying, what it does to get the content on the screen quickly is render it in chunks. So what that looks like, so we have this render ahead distance, and we have the viewport. So first we render some initial page size, maybe like 3 rows, really depends. And then we render in these sort of chunks or pages of rows. So in this situation, the page size is 2. So we render up until we reach the end of this render ahead distance. And then when the user scrolls down, we need to page in more rows because this render ahead distance now isn't completely filled. And that continues. So one really important thing to notice here is that the rows above the viewport are staying around in memory after we scroll past them. So if we had 1,000 items in our list, those would all stay on the screen. And so for people who haven't done native development and you've done like web stuff that maybe involves large data tables, you've probably used something like React Virtualized, that sort of thing. And that's very similar to this other concept. So to solve the problem of having all of these views, thousands potentially in memory at a time, Spencer, who works at Facebook on the React Native team, came up with something called windowed ListView. So what it does is rather than just having the viewport and some render ahead distance and keeping all the rest of the rows in memory, it will just render rows within a certain window and then remove the rows as you scroll past that. So what it does is, right, rendering, get those. Now the viewport moves down. We could see that that's shifting the total number of rows that we're going to render. So we shift our window down, and then we replace the other rows up above with the spacer, and finish rendering that. So I think at first glance, like this seems like, all right, this could be a good solution. But of course, there are trade-offs with that as well. So windowed ListView is more CPU intensive than the regular ListView because we need to, anytime we scroll back up, we need to now recreate these rows as well. And you need to be able to render them quite quickly because if you were to scroll up very fast to a part where it was just a spacer view, you're going to see like a blank screen for a bit. And yeah, that's not really ideal. So as it turns out, one of the most important APIs for mobile development is the ListView API for your platform. So whether that's like UI table view or ListView on Android, these are essential. You just have to learn how they are used. You use them everywhere. So they're significantly different from React Native's ListViews because they actually reuse the rows. So what I mean by that is, so here we have some rows in this list. We scroll off screen, and we no longer need this row, so now we move it into a recycling pool. Once we scroll down again, and we need to render another row, we pull it out and transform it into whatever the row should be in that position, and just basically keep repeating that. So side by side, this is what they all look like. And ultimately, unfortunately, we don't have like UI table view or UI collection view in React Native yet. So what we had to do was kind of decide, are we going to use ListView? We're going to use windowed ListView. Yeah, what are we going to do? So we decided we're actually not going to use either of them. We're going to make something else. And it's actually very similar to ListView. But what it does is, rather than rendering in the page sizes, let's say 2 at a time or X at a time, we can have a larger page size, and so we render in larger chunks, but that we don't block the JavaScript thread for that entire time. And how we do that is, as usual, first we render some initial page size, then we render these transparent views. And so you can see that on the left side, that's the normal list view. On the right side, we have this, what I call incremental list view. And so once it gets to the point where it's rendered the full page size, then it reveals those rows. And so this is really what you want when you have a feed screen, because you want to get to the bottom, show the loading indicator, and then once you've rendered all the new stories that have come in, or whatever they are, then you want them to all reveal at once, rather than in groups of 2 or whatever, so that you repeatedly hit the bottom of the screen. It's not useful everywhere, but for feed screens, it's quite useful. So yeah, that's what it ends up looking like. So like I said, there is no solution right now for UI table view and view recycling in React Native. This incredibly intelligent guy named Nick Lockwood has done some work on it, but he's not currently working on it right now. So if this is something that you're interested in working on, you should definitely reach out, and I'm sure he could guide you on how you might be able to get started with that. Okay, the next point here is to offload your animations. So hopefully you all attended Christoph's talk yesterday. So you have some background on what I'm talking about, but just to briefly recap, so as we saw in the previous section, it's pretty easy to get into a situation where you're blocking the JavaScript thread for a few frames. And what happens is that because the way that the animated library works is that every frame it has to call back into JavaScript to update the animation value. If you block for even a few frames, then your animation is going to jitter, and it's not going to look very good. So one solution that has been with React Native since the start is something called Interaction Manager. And so what this does is it allows you to pass in a callback that is executed after all animations or gestures are completed. And so what you can do is when you're mounting a screen, you can set some state like isReady, default it to false, and then inside an interaction manager block, say, okay, set it to isReady true when you're done, and then basically defer rendering that screen until you're done the animation. But we learned that this can actually lead to some pretty slow feeling apps in some situations. And the reason for that is that this is sort of like the rough timeline of what the JavaScript execution looks like when you're using Interaction Manager. Right? You'll see that we handle the press, and then we perform a transition. Once the transition's done, we fetch the data, then we'll update the store, and then render the scene. And this is just we're sequencing one after the other, being very careful to not do anything that could drop frames. By offloading the animations to native, we can kind of compress it like this, where we're performing the transition. We're not so concerned about what's happening at that point, because this is all being executed on the main thread or on some separate native thread. And so on the JavaScript side, we can do whatever, and if we drop 10 frames or whatever, it doesn't really matter. The user won't feel it. That said, it is very possible that the scene that you're rendering will be also quite intensive for the main thread. So for example, if you're rendering a map view, that usually would cause some frames to be dropped on the main thread. And so what you might want to do instead is something like this, where you could still do whatever JavaScript logic that you want, and as long as you're sure that it's not going to impact the main thread, then you should be okay with that. And overall, it's a net win. So in our experience, it made the app feel considerably faster to offload these animations. But our original motivation there was primarily for Navigator and this photo gallery that we built. But it's actually been useful pretty much everywhere. We use it for when you tap or relist something, because there are times where maybe you're already doing something else in that frame, and then you like something, it dispatches this action, does a request, and maybe causes a frame drop or something like that, just some sort of slowdown. So in those situations, it's really nice to just basically just be sure that it's going to run smooth. So as an aside, so I don't know if Christoph mentioned it yesterday, but we contracted him to build this for us because we knew it was something that was quite important and that we really thought was necessary in order for the app to be performant while written entirely in JavaScript. And I think that this is a really good model to follow. I think that if you're a company that is invested in React Native or you have some potential value coming from it, that you could find people to build things for you that aren't just your proprietary solutions, but that the whole idea is you're going to build this and push this upstream. So an example of where that would be very useful is in the view recycling. So if anyone's interested in that, again, definitely let somebody know. Okay, so Eric talked about navigation a bit yesterday. I'm going to talk about it a bit more. So in the first talk I gave about React Native just about a year ago, I kind of bragged okay, in WebView-based frameworks you have to re-implement all of the UI, whereas in React Native you could just use the native UI everywhere, right? Well, yeah, you can use the native views in many places, but you can't use all of the native functionality. There does exist Navigator iOS in React Native where you can use the underlying UI navigation controller, but you lose out on the cross-platform benefit, and it's just not as customizable as you would like from JavaScript. So a navigation API is a really central piece of any mobile app. So if you compare it to the web, maybe a somewhat comparable library would be React Router. But the big difference is that in the web, you don't actually have to use React Router. You don't have to use anything. You could just use the built-in URLs and page refreshes to do whatever you need. You don't have to support swipe back transitions or all these sorts of things. And you just get URLs by default. So this isn't the case in React Native. You have to use a navigation library of some sort. So React Native shipped with this API called Navigator, which was really more of an experiment at making cross-platform navigation work, and it kind of mimicking Navigator iOS in the API. It was a really good first attempt at solving this very complex and nuanced problem, but it made a few things kind of tricky for us. One of them in particular was the ability to offload animations. So Navigator was built before the animated API existed, and so you're unable to offload those animations to native. And so a big driver for us in switching to base all of our navigation on Navigation Experimental is that it's powered by animated, and so we were able to offload those. We spent a lot of time working on navigation-specific code. Our X navigation library has about 3,200 lines of code. There's about 1,600 project-specific lines of code directly for navigation, and probably another 500 or so just spread throughout the app, co-located with components. So you really have to expect, if you're building something that's beyond switching tabs, pushing and popping routes in a very basic sort of conference app kind of way, that's something that would be quite easy to build. But if you have something that has even a little bit more complicated requirements, you're probably going to have to dig in there a little bit right now. There really aren't any best practices yet. It's just, like Bonnie was saying, there's just good enough practices right now. So James wrote this X Navigator library a while ago, and now one of my coworkers, Skevi, wrote the new version of this library called X Navigation, which is based off of Navigation Experimental. And the main sort of goal of this is to provide a user-friendly API that's a little bit opinionated towards how we like to build applications, and built on top of Navigation Experimental. So hopefully, another way to think of it is X Navigation is how to even for dummies, because I'm sure people will use React Native and go, I can't even with navigation right now. Yeah. Ooh, that one fell flat. User input text, here we go. So user input, there's lists and there's input. Those are key foundations of any application, right? So user input also has a few difficult things. There's keyboard events. So the keyboard behaves a little bit differently on iOS and Android, and how it's factored into the layout. And you have to watch for keyboard events all over the place. And then in response to the keyboard appearing, you have to do something to change your interface so that you're able to see the content that would have been occluded by the keyboard. So in this case, we just add some extra spacer to the bottom so that we push the content up and are able to see what we saw before opening the keyboard. I don't know if there's a better solution than just adding watchers everywhere right now, but that's pretty much what we do. Sometimes you need to control the cursor position, so it's very common to have like a controlled text input where you have some onChange event, and then in response to that, you update the value of the text. If you ever change the length of the text in response to a change event, then you have to actually make sure that you update the cursor selection position. Otherwise, it's going to appear like it does on the right there, where the cursor just doesn't go where you want it to go. And that just adds like another little bit of complexity there and how that's handled. And this could be something that could be solved at some point, but yeah, you're still going to have that problem. Another thing that doesn't come built in with React Native is some concept of like a growing text input. So pretty much every time you have multi-line text, or well, not every time, but really a lot of the time when you have multi-line text, you probably start off as like one line, and then it grows as you add more text to it. So think like when you're in Messenger and you're writing, and the message text box grows in response to the amount of text. So we just made a component that handles that, and so you're welcome to just grab that and use it, and I would probably recommend that. Although I need to push a fix upstream so that that works for everybody. Sorry. Okay, touch and gestures, another kind of user input. If you're interested in this at all, definitely check out from ReactConf. Andy Matuszak spoke about this. He did a lightning talk, but he knows all about this. He worked on UIKit and the gesture system, and he did an awesome job of explaining why it's so complicated. And this is a big unsolved problem with React Native right now. But you can pretty much get around most limitations in fairly, if your app isn't completely gesture-driven, without too much work. So we ran into 3 specific problems. One of the problems is that the gesture system doesn't work very well when a couple of components are interested in a single touch event. So if you look at this example here, there's touchable, which is like, it's just a component that responds to some kind of press event in React Native. And then we have a touchable inside of it. So that you would maybe suspect that, okay, if I have this touchable that responds to on long press and then this inner touchable that responds to on press, that if you match a long press, that the outer touchable would handle that. But actually, it never gets there. And so that can be a little confusing sometimes. And in fact, the specific case where I ran into this problem was having a text input with a touchable wrapping it. So I wanted to make long press on a text input, but the text input would always claim this responder status. It would always try to say, okay, I want to be the one who handles this touch, forget everyone else. So the solution, I've linked to it down there. It's not very pretty, but like I say, it works. And this is what we used it for. So we're able to like drag and sort in this thing. There we go. Yeah. The second problem we run into is that if you have a view that can become the responder and it's inside of a scroll view, if you don't respond immediately, if there's maybe like any sort of delay on the JavaScript thread, then it will just start scrolling in the actual scroll view until you have a chance to say, oh yeah, actually, this is an event that I'm interested in. So what you see here, I've simulated a 300 millisecond delay in responding to the touch event and claiming the responder. And so you can see that it kind of scrolls the scroll view a little bit. So that's a slight issue. Okay, and the last one that we ran into is you can't really reliably animate views in response to a scroll event. So there's this header component in the F8 app that is actually implemented natively because it's just too easy to get into situations where you're dropping a couple of frames, and it looks quite bad when your scroll continues, but this one view that's supposed to be animating at the same time doesn't. It would be better if all of it froze, like as you see in a lot of native apps. The main thread will maybe freeze, and then you won't be able to scroll, but also none of the animations will happen. Whereas in this context, if the JavaScript thread stops responding every frame, then what you get is basically the scroll continues happening, and the animation that you're expecting just sort of freezes temporarily. So yeah, the solution for that right now, the only one is native, writing a native component for it, although Christoph has been working on a potential solution using animated. Okay. Shared element transitions. So this is a really common UI pattern on mobile apps, but the support isn't great for it in React Native. I mean, it's really not great for it anywhere. Like, I was discussing with Christopher yesterday that this exact slide, and he pointed out that yes, okay, there is support for it on the newest version of Android, but if you, of course, need to support other versions of Android, which everyone does, then you pretty much have to write some other custom solution. And so what we had to do here is create 3 different versions of this view. We have to have the image that exists inside of the list, then we have an image that animates in, and then we have an image that sits inside of this image gallery. So let's say somewhere in our app we have this image and the user taps on it. In response to the tap, we create this new image. We need to set the dimensions of it and the position to be the exact same as what it was in the list, and then we need to animate that to the target that we're going to. And once that animation is complete, we just hide that image and reveal this other image in the image gallery. So you'd think, okay, great, that would work. But actually, that's a little more complicated still because you don't have a concept of z-index in React Native. And so now you have to worry that, okay, if I have a tab bar or a navigation bar, this is all going to appear underneath my navigation. So what you have to do is then like hoist up the image gallery to the top level of your app so that it appears on top of everything, because z-index is kind of implicit based off of the order of components in the app. And so it would look something like this. This would be at the top level. But to save you some trouble, I open sourced this example, so you can check that out on GitHub. And yeah. So next section, living in production. One really great thing with React Native that I think most people are aware of is that you can do over-the-air updates. So here we're just like pressing this publish button. It publishes a new version of the JavaScript bundle that runs the app, and that's really awesome. So Code Push, Exponent, App Hub, whatever, they let you specify a target native version, but really this isn't a silver bullet. You have to be careful that you don't deploy JavaScript that depends on some native change. And we recently did this and accidentally included a change that referred to a new native API, or rather renamed native API, and we had to revert once we saw a bunch of crashes. So you have to keep in mind that, like, you know, you have a lot of power, but you've got to wield it carefully. Yeah, Spoderman. Another one is source maps don't always work perfectly. So thankfully, Tadu mentioned this optimization that helps with like require caching and improving startup time. But actually, this breaks source maps, so that sucks because this underscore D thing that you saw like exists outside of the regular transform step, and so it just sometimes it works. Sometimes you get things like this where it's like, oh, there's this handle press thing on this line, and it refers to some component. So that's pretty unfortunate, but there's definitely a fix for that, and that's just part of using it right now. But the app is very stable. Like, in spite of this, our crash rate is very similar to the native iOS version of the app, and we're really happy with it, and people are really enjoying it. So the last part is contributing back. I assume everybody here uses React, and probably very few of you have actually made any upstream contributions to React. That's not to say that's a bad thing. I think that's really common. I think, however, that should not be the case if you're using React Native. Because React Native is so early and the scope is so huge that if you're using it, you're going to find places that nobody else has run into, that nobody else cares about, and you can be the person that can solve that and submit a fix for it or whatever. So this is just like an incomplete list that I put together in a few minutes of like upstream contributions that we did while building this project. But in addition to that, there still aren't tons of like really well-polished libraries out there, so you're probably going to have to also build a lot of the things that you're going to use in your app. So that's something to definitely be aware of. And the result of that is if you want like a really highly polished app that works very well, it's going to take a long time. Like, thankfully, it will take less time, and as time goes on, it's going to take less and less because more of this is being developed. But the case is right now is it just took significantly longer than we'd hoped that it would take. We're confident that we could build the same sort of app in maybe a third of the time as it took last time because we have all of this knowledge and these components and fixes that we came up with while we were building it. But you never know if the particular app that you're building is going to be a path that anyone has gone down before and actually contributed their fixes for. So yeah, basically in conclusion, building a large polished app with React Native right now is possible. If you're using custom native components, it's, I don't think, particularly difficult. If you're using just JavaScript, it's going to be a decent amount more complicated because of limitations like certain cases of handling input are a little bit more complicated, and certainly gestures, list views with recycling, that's a huge issue that hopefully should be solved soon enough. But yeah, for now you might just have to write some native views. But I really think it's worth it, and as people keep building more apps in it and developing this framework, it's going to be like pretty amazing. So I would definitely recommend that you try it because yeah, you don't know what you could potentially build with it. And one last thing, if what I've discussed today is at all interesting with you, or to you rather, List is hiring a React and React Native developer to work in Venice, Los Angeles, California. So just let me know. All right, thank you.